Greetings fellow earthlings and welcome to this tiny garage. Last week was a big week in the tiny garage. Finally, after a lot of nuts and bolt undoing, we got the engine out. Now that is a big step, but really it's just the beginning. It allows us now to have easy access to everything in the engine so that we can fix it properly. Now we know that we have a suspected IMS issue, which is very common on these engines, but we know for a fact that a bunch of the timing chain plastic parts fell apart and spewed their pieces all through the engine. The first thing to do is take off the transmission. My neighbor, bless his heart, gave me this ATV motorcycle stand, and so I'm going to use that to secure the end of the transmission. And so here I'm using these come-along straps to strap it onto that ATV stand. That allows me to raise it and lower it and just make it be exactly the same height as the engine. You don't want any kind of strain in any particular direction when you're trying to remove the engine and transmission from each other. You can see the bolts there that attach the transmission to the engine. The heads of most of them are 16mm. I was expecting that they all kind of were the same, but slowly as I started taking them apart, I realized here that they were all different lengths and some of them were just a different kind of fastener. And so I wrote numbers on the bell housing and on the heads of those particular bolts. This one here is the dreaded triple square that we'll talk about a little bit more later on. And I thought for a second I was home free, but I wasn't. And so on the other side, there is a nut and bolt combo that has two 15mm on each end. And so here's the big moment, a little bit of rocking, and what you can't quite see from this angle is that immediately it started coming apart. Like right there, you can see inside. Once you wiggle it back a couple of inches, the spline shaft comes out from the pressure plate and the transmission is free. And yes, for a second there, I did feel like one of those magicians that had just cut someone in half. If you're enjoying these videos and you'd like me to make more, the best way to tell me is to click that subscribe button. As you saw in that video, I certainly was surprised at how easy it was to get the engine and the transmission apart from each other. You just undid the bolts and really they just came apart. Now, that's one thing when the engine and transmission are out of the car like this, but for any of you who are working inside the car and you're trying to get the transmission or engine out separately, you will really want to know this. And so I labeled these because I was about to throw all the nuts and bolts in a pile and then I realized they're all quite different. And so here's what you would want to know. The bottom one here, this is the passenger side, that is the front of the car facing that way. So the bottom bolt, number one here, that is a triple square. What's a triple square? I had never heard of a triple square before. No one at the local car parts stores had ever heard of it. But in the big picture online, they are really quite available. If you imagine if you take a square and rotate it 2 more times, you'd have 3 squares or a triple square with 12 corners. And so this has 12 corners, kind of like a very cornery star drive. And so that, other than that, it's really not special at all. And so it goes into this one bolt. It's the only one like that on the entire transmission. Number one right there. Then we move across to number 2. The majority of the rest of them are all 16mm, the heads. But this one is 3 inches long. Now if we go to number 3, which is right here, this one is 4 inches long. Then we go to number 4 here. That one is also 4 inches long. So 3 and 4 are the same length. Now let's move to the other side and see what's going on there. So here we are now on the other side, and so the transmission, I turned it around, so that's the front of the car, where the front of the car would be. We just came up this side, the passenger side, 1, 2, 3, and 4, and so here number 5, it's very similar to the last fasteners we were working with, 16mm, and this one is 3 inches long, and then number 6 is the same, 3 inches long, 16mm. And then number 7 is 16mm head on it, but it is 2 inches long. It's the shortest one there. And then the next one is number 8 at the very bottom. It's the opposite side from the triple square, and that one is the only one of its kind. It is a nut and bolt combo, both 15 millimeters. So there we go, that's it. That's the riddle of these 8 fasteners that join the engine and transmission together. The first thing that you encounter when you take the transmission off the engine is this clutch pressure plate. Now here I'm putting some white out just across all of the different components, just in case I messed something up and I kind of know how they went back. There are these locating pins on the pressure plate. Now if I was doing this again, I would have put some WD-40 on those locating pins as well. It would have made it easier in the end to wiggle it off. The pressure plate itself is held on with these H6 Allen wrench bolts. The first one that I undid got stuck on the bit itself. It's as if the bit wasn't quite large enough and it rotated ever so slightly and got stuck. So I ended up putting that into a vice grip and then just putting the socket drive on it but the opposite direction, and it came off pretty easy. That was the only one of the bolts that did that. All the other ones came off just fine. So wiggling really is the instruction here. Try to find an area that starts moving and try to increase on that. Like I said earlier, the WD-40 on the locating pins would have helped. You don't want to go too crazy with the WD-40 around clutch surfaces. It doesn't want to get onto any of the clutch. That stuff does not want to be slipping. With this stuff, as it turns out, I'm throwing all of it away, and so it doesn't really matter if the WD-40 gets on anything. So there, in the end, it did just pop off. It took a bit of wiggling to make that happen. And there is the clutch disc itself. Now, I haven't done this before. I don't know if it has a front or a back. I'm just marking on there. As with everything that comes off, just in case, I'm marking kind of the orientation that it came off the car. Now, here I am trying to get rid of all of the clutch dust. There's a great deal of clutch dust. It's like brake disc dust, very similar. Because there was so much of it filling up the star drive hole that I was worried I might round out the fastener itself. And so using some brake cleaner and a stiff brush, and then also using that respirator, believe it or not, really helps. That stuff will get you really high, but not in a good way. And the respirator really helps with both the smell and also, the effects of the inhalant. And then using the T55 star drive, it was too much torque really. The engine would just move too easily. If you had an air gun and were able to put a really quick torque onto those bolts, you might be able to get them off. In this case, what I used was something you would use to draw 45-degree angles on a piece of wood, to be honest. But it happened to fit exactly into the teeth of the flywheel. And so using one of the mounting bolts from the transmission, that was good enough, certainly good enough to hold the bolts while I undid them. Now, putting those back together again, I'm actually going to use the real thing, some sort of flywheel lock. This is what the actual Porsche flywheel locking tool looks like, and for something like $100, that little thing will do a great job, I'm sure. By the time we put the new dual mass flywheel back on, we do need to have a proper way to hold that flywheel because we have to torque the bolts down. And for that, I don't want to mess around. And so I did purchase a Volkswagen flywheel locking tool that, according to the forums, can be adapted in a simple way to hold the flywheel very effectively. Hey, look, it's a clutch. Now, I may have pressed a clutch pedal many thousands of times in my life, and I know all my European brothers and sisters certainly have, but this is the first time I've ever held a clutch in my hand. Now, what does a clutch do? Now, if any of you have ever asked anyone that knows what a clutch does, I know I certainly have, you get some sort of explanation like this, right? And then like a 9-year-old in sex ed class, I'll normally go, all right, well, I guess I get it. But we have all the bits and pieces apart right now, and it's a great opportunity to actually see what a clutch does. So what is a throwout bearing? What's a dual mass flywheel? Is it better than a single mass flywheel? Isn't more more? Let's take a look. So starting at the beginning, here is the clutch pedal, and for many of us that is all there is to the clutch system. But let's take a look at that clutch pedal in more detail. So here it is, and at the bottom there is the rubber pad that you push with your foot, and then at the very top it has a pivot to allow it to move backwards and forwards. And then onto that there is a spring, a return spring that's attached under the dash that pulls the pedal back when you take your foot off. Now when you do press down on the pedal, it's pushing a master cylinder, which if you want to imagine that when you push down with your foot, that master cylinder is kind of similar to pushing down on a plunger. And so when you push down, you're pushing fluid through that system. So here's our master cylinder. Now when you push down on the clutch pedal, it's kind of the same thing as pushing down on this plunger here. Now this is called the master cylinder because it tells the slave cylinder what to do. Now here's the slave cylinder. Now as you can tell, it's a complex system. And so when you push down, uno momento. When you push down on the clutch pedal, it pushes down on the master cylinder, and that, yay, makes the slave cylinder pop out. It does a reciprocal action. Now on the transmission, in this case, this pushes out and pushes against the release arm inside the transmission's bell housing. So this is the area where we took the clutch slave cylinder off, and through that hole is where the plunger pushes on this release arm, and it pushes that arm forward. And then attached to that arm is the clutch release bearing, also known as the throw-out bearing. And you can see that circular thing in the center there that it pushes it forward. And so that throw-out bearing, it needs to be able to spin as it gets pushed forward onto the clutch release plate. So from that throw-out bearing that's pushing forward when you press the clutch pedal, what that does is pushes on these fingers of the pressure plate. And you see there's a lot of fingers, but for the sake of our demonstration, imagine there's just one finger, that finger. And so this guy, when you push it in, you would think that when you push this in, that's then pushing the clutch onto the engine, right, and making it work. But it's the opposite, and the way it works is each of these fingers is like a little seesaw. So when I push on this guy here, there's a pivot point underneath this plate, and it actually makes the end pop up like that. So if you imagine with all of these fingers popping up at the end, the effect it has when you push the clutch pedal and the throw-out bearing pushes in here, what it does is makes the clutch pressure plate pop back and stop pushing on the clutch. And so let's have a look on the other side. Here is the clutch pressure plate. And so if we grab the clutch here, that fits in there very nicely indeed. And so what this pushes onto on the other side when it clamps down is the flywheel. Now on many cars it's just a relatively solid piece of metal, but on the Porsche it's called a dual mass flywheel, because these two pieces of metal are able to rotate a little bit separate from each other with a spring system that's on the inside. Now if you look at this clutch plate doesn't have any springs on it, and most common clutches have springs in the middle, and the job of those springs was to, what my understanding was, and it is true up to a point, was that let's say for example you're at a stop sign and you put the revs really, really high, which you shouldn't do really, but then you decided just to drop the clutch really sharply, which is a terrible idea and you shouldn't do that, and then shoot off at an extreme rate of speed. Well, that would put a lot of strain on like your engine and your drivetrain and everything, as this clutch went boom straight onto the power from the engine. And so the idea of the springs on a clutch is to allow a little bit of movement, and that it takes away that initial sort of shock. And that was my understanding, and that is true. It does do that job. But another thing it does is the engine itself, as we talked about before with the leak down test episode, was that there's explosions going on. And so every time a cylinder fires, this crankshaft is doing like boom, 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 boom. And there's a little bit of vibration just from each one of those explosions. And so those springs soak up that vibration and resonance as well to smooth it out. So in your seat of the car, that it seems all a little bit smoother. And then also the components all involved in that system have less vibration and shock overall. So on the Porsche, they do it a little bit differently. And this is solid, no springs. And so the springs are, mother of God, are in this dual mass flywheel, which is very heavy. And I have a weighing scale here, actually, just so happens. And so let's put that on there. Jeez. Okay, it is, oh, it doesn't seem that bad. It's like the weight of a small child. 30 pounds, 1 ounce. But in this small little package, that is quite a lot of weight. The idea here is it's the same deal, but a different way of doing it. And so this large weight, as you can imagine, is again even more capable really of soaking up those shocks and those resonances and those vibrations from just the regular operation of the engine and the way you might drive.
Let's say you want to actually go somewhere. You let your foot off the clutch pedal, the slave cylinder retracts, the release arm moves back, moving the release bearing with it, which lets go of the clutch pressure plate fingers, which causes the pressure plate to clamp the once stationary clutch onto the flywheel that's spinning with the engine, causing the clutch to spin with the engine. Now, why do we care? Well, the simple fact is that of all of these items, the only one that is connected to the transmission spline shaft is the clutch. And if you rotate the spline shaft, you rotate the wheels.
That is how the clutch system works. We need to talk a little bit more detail about this dual mass clutch. I had some advice from Arnold Mosk, one of our subscribers. Hello Arnold, thank you so much for your advice. And so I was thinking, like so many people, that I would swap out this dual mass flywheel for a single mass flywheel because it's so heavy. And so if you put a lighter one on there, the revs would climb quicker and it would make the car seem a bit more racy and all that kind of good stuff. But the downside of that is you would lose all of that resonance protection and also some of the mass, I understand, from this spinning can help you if you're idling at a stop sign or something, like a normal person, and it might cut out because the engine doesn't have enough mass for what it's expecting to keep running. And so for those reasons, and also trying to not screw things up too badly, I'm probably just going to stick with the stock system. I did measure the spring travel on this dual mass flywheel, and so let's take a look at that test and go from there.
To measure the condition of the dual mass flywheel, you're supposed to mark a point on the front and back of the dual mass flywheel and then rotate it without pushing too hard and see how far it'll go in either direction. Then you measure that deflection. It says up to 15 millimeters in either direction is okay. Both of these were under 8 millimeters.
So while our hefty dual mass friend here may seem to be okay in the deflection front, one other aspect of it is the condition of the part of the metal that touches the clutch. And so in the case of this particular plate, obviously I've never seen them before, so it's difficult to judge, but one of the things they say is if it does have any scoring, that you need to just replace it. You can't recover these, sorry, not recover them, you can't recut the surface, like level the surface out with some lathe or other. You have to just replace it. And while it pains me to do that, because I don't really talk about prices on here, but if you went to Porsche, this would be expensive. I mean, the cheapest I've ever found it is $500 for this guy here. Any of you eagle-eyed observers will have noticed that this car seems to have a newer starter motor here, which is encouraging. And I'm also noticing that, for example, with the brakes too, the brakes seem like newish, like refreshed somehow. And so that helps me feel that at least this car wasn't completely ignored all of its life. And so yeah, it's pretty obvious it has definitely been replaced by somebody who knew something about something in order to be able to get that thing in. So good news, and we'll put that on the good side.
From day one, the premise of this video series has been this car's suspected involvement in the famous IMS bearing issue. Well, finally, here we are, face to face with the IMS bearing flange. I need to clean this area up anyway, and I also need to clean it up to help identify which type of IMS bearing this engine has. This Carrera is a 2001 model year, which means it might have a single row IMS bearing or it might have a dual row bearing, as Porsche were transitioning from dual row to single row in that year. So the only way to know which one you have is to take the flywheel off and have a look. From other horror stories that I've seen online, this area is often wet with oil that has leaked from the IMS bearing flange or from the rear main seal, or very often from both. Prior to cleaning the area up, I noticed that it all seems to be clutch dust. No oil was leaking out between the transmission and the engine. That area was completely dry. As I have no prior experience to rely on, I sent a photograph of this area before I cleaned it to LN Engineering in Illinois. They're a company that specialises in redesigned IMS bearings. They seem to agree, mostly clutch dust, though they said it's likely that the RMS was weeping a little and that encouraged the dust to stick in that area, but no major splurge of oil, which could mean that the IMS bearing has not completely fallen apart. Again, that is another thing that could be good news. Regardless of their condition though, both the RMS, the rear main seal, and the IMS bearing will need to be replaced. So which cars are affected by this famous IMS bearing issue? Well, starting in 1997, all 986 Porsche Boxsters and all the non-turbo 996 Carreras had dual row IMS bearings. Then from 2000 to 2001, Porsche started to use the single row bearing, and so at that time, like my car, some cars have the dual row, some cars have the single row. Just kind of depends what they had lying around at the time. Perhaps it was that simple. From 2002 to 2005, all those cars, just the non-turbos, but all the Boxsters and all the Carreras, came with the single row bearing. By the time the 997 Carrera came out in 2005, Porsche were well aware that there was a big IMS problem, and so they redesigned the IMS bearing into a larger single row design. And so it's thought from basically 2007 on, if you have one of those cars, or of course a turbo car, then IMS need not be a worry of yours. With everything all cleaned up now, it's easy to see that yes, I do have a dual row bearing in this car. Of the two designs, that's definitely the preferable one to have. You can see in this photograph here that the dual row bearing literally has two rows of bearings, and that gives it double the load capacity of the single row bearing. From the numbers I was able to find online, it seems that the single row bearings have approximately an 8% failure rate, whereas the dual row IMS bearings have a less than 1% failure rate. I'm going to enjoy the fact that it does look a little bit cleaner now, but it is of course still very broken.
So now that we've got all of these parts off, I've been trying to assess their condition. Now, as you guys know, I've never done any of this stuff before, and so I don't have anything really to reference as far as what the condition of these parts are. Now, after the research I've done, and that included, I posted photographs of the dual mass flywheel and the clutch and other stuff online and sort of asked opinions from Porsche-based forums and stuff like that, what people thought of these items and whether they were worn out or not. And the end result of that, I mean, there's quite a lot to it really, but with the dual mass flywheel, even though the deflection is good, and if you were stuck in the middle of nowhere and you just had to get the car going again, then for sure you could stick it back on. But if we're trying to resurrect this car and do it properly, then the dual mass flywheel, the front of it, I'll show you in pictures, is probably better. It's kind of burnt and very lightly scored, and so if that's the case, really it's considered a wear item, and these ones, because they are a dual mass flywheel, you can't, as I said earlier, you can't turn them or stick them on a lathe or anything. So it has to be thrown away, and we'll get another one. And so that's an interesting decision coming up as far as what to replace it with. We did talk about doing this solid flywheel, and then there's also, obviously you just go to the Porsche dealer and you buy another one. But then there's also the Luke replacement part, which is the original equipment manufacturer approximately, I think. I'm sure you guys could tell me in the comments. So here is our many-fingered friend, the clutch pressure plate. And with this, you just throw it away. You just replace it. Crazy, I know. With a lot of the clutch parts and the system in the transmission that we spoke about today, you just throw them away and you buy new ones. And so we'll talk about that as we get closer to it, because right now I don't even know what the choices are. But that's going to be interesting, assuming we get to that point, if we have luck getting this engine back together. So what about the clutch itself? That is the ultimate wear item in the transmission system. And so I did a bit of research, and looking at it, there is quite a lot of meat left on it. It was difficult to find the actual number for how thick a new clutch is, but it turns out just over 8mm is the number. And so I have a digital micrometer here, and measuring the thickness of the disc, really 7.9, 7.8, that kind of thickness is really pretty close to a newish clutch. And so that's encouraging. And so obviously many of you would get very upset if I didn't replace the clutch itself. And so of course I'm going to replace the clutch. But it is encouraging that it doesn't have tremendous wear on it. And like the starter motor being sort of fresh-ish, and the brakes also looking refreshed in the not so distant past, it does make me feel like at least somebody spent some money trying to keep this car in decent shape. And so that's, again, we'll put that on the plus side. This week has been very educational. All this talk about the clutch and its operation got me thinking about one of those common questions that comes up. Is it okay to leave your foot on the clutch when you're stopped at a stoplight? Now, I think we know enough about the system to answer that question. If you leave your foot on the clutch, what you're going to do is push that throwout bearing into the fingers of the clutch pressure plate, which is spinning at the speed of the engine. Now that's going to make that bearing spin at the speed of the engine for the entire time that you're sitting there waiting to go. And so sometimes you have to do that. But as we know, the more you run a bearing, the more likely it is to wear out. And as we've seen in these videos, it is a lot of work just to get in there to replace any of these parts. So the advice would be, if you're out driving around downtown Manhattan on Christmas Eve, it might be an idea to put the gear into neutral and take your foot off the clutch while you're waiting for that light to change. Unfortunately, that is all we have time for this week. Thank you very much for watching. Till next time. It's a clutch! I don't know what to do with it now. When you push the clutch pedal in, so push down on the clutch, the slaves...